Hi, my name is Justine Harkness, and in this video we'll be comparing SN1 and E1 reactions. There are a lot of similarities between SN1 and E1 reactions, and to better evaluate these similarities, let's do a side-by-side comparison. Here we're going to look at the substrate, the solvent, the nucleophile versus the base, and the product. So first of all, for both SN1 and E1 reactions, we need to have a secondary or tertiary substrate. And the reason for this is that the first step in both of these reactions is the formation of a carbocation intermediate, and really only secondary and tertiary carbocations are stable enough to form in solution. Both reactions also use a polar protic solvent, and this is to both help stabilize the leaving group after it is departed, and also to stabilize the carbocation that is formed. One of the differences that we see between these two reactions is the nucleophile versus the base. In an SN1 reaction, we use a weak nucleophile, and in E1, we use a weak base. However, let's dig into this a little bit more. So an example of some weak nucleophiles would be water or something like ammonia. They both just have lone pairs of electrons, and that's what makes them nucleophiles, but because they don't have a full negative charge, they are weak nucleophiles. However, both water and ammonia are weak bases. And this is why SN1 and E1 reactions compete with each other. They have all of the same substrate solvent conditions, and also weak nucleophiles can be weak bases. The main difference is what we get out of the reaction. In SN1 reactions, we'll get substitution, whereas in E1 reactions, we will get elimination. One of the main determining factors that you can look for to determine if you're going to undergo SN1 or E1 is the presence or absence of heat. Heat will always favor an E1 elimination pathway. So let's take a look at an example and evaluate the different reaction conditions to see how the reaction will proceed. So in this question, we're given a 2-bromo, 2-methylbutane, and it's reacting with water. And the student here is predicting that our major product will be the result of an SN1 reaction, and we want to know if this student is correct and why. Now, if we look at how this reaction will go, the first thing will be to form the carbocation intermediate, and this would be the intermediate in both SN1 and E1 reactions. Now, if we were to undergo an SN1 pathway, we would get what the student predicted as our product. And if we were to undergo E1, we would get the formation of a double bond. Now, the big indicator here that will help us to make our determination is that we're doing this specific reaction at 95 degrees Celsius. This is really close to the boiling point of water, so our reaction conditions here are very hot. And remember that E1 reactions are favored by heat. So in this reaction, we are going to favor the E1 pathway because of the high temperature, so our major product would not be the substitution product, it would be the elimination product. So to answer this question, this student is not correct, and it's because the reaction conditions are those that would favor an E1 reaction. So now you should be more comfortable evaluating the different things that contribute to SN1 versus E1, and specifically using the presence or absence of heat as a key indicator to predict the product of the reaction.